What's up guys, it's Novice here and I'm back with another video. So in this video we're actually going to continue what we started in the last video, and we're going to continue to build out our password cracker. So just for recap or reference, if you guys haven't watched the past video, I'd suggest going to watch it. But what we did there, we created a class for the MD4 hash as well as the NTLM hash. Now, as I mentioned in the previous video, these hashes are important when it relates to password cracking, because when you're cracking passwords, most of the time you're going to be comparing password hashes to password hashes, not actual words to actual words. So without further ado, we're actually going to continue on, and today our main focus will, instead of being on MD4 or the MD family, it's actually going to be on SHA1. So with that, I'm going to go ahead and switch my screen over so you guys can see, and then we can start building. So as you guys can see here, we're pretty much left off at the exact place where we stopped last time, testing out if MD4 worked and if NTLM worked. So today we are going to test and build out the SHA1 function, well, SHA1 class. So here we're going to create a new file. Go ahead and call it SHA1. Oh, whoops, let me actually make sure it's a Python file first. And then we're gonna go ahead and do like we did in the other one, import struct, and then from there we're actually gonna create sorry, thinking about functions right now, the class of SHA1. Now from there we're actually gonna create the initialization function. Go ahead and hit them with the init. Now from here, we're simply going to put self.password equals password, and that's what we're going to use to create the, or encode as we go along. I know that you see what's recommended on here, but we'll get to each thing as we move forward. I do not need the rest of you. Let's just press enter, enter. Cool. So that's the first function, which is just initializing the class itself. Next, what we're gonna do is actually create the UTF string conversion. So with this one, since we created this in MD4, we'll also create it here. So the first step in making something SHA1 is also to have that same exact, or to convert it into ASCII. ASCII can be created using UTF-8. So we'll just go ahead and repeat the steps here. Next up, it's crazy that there are so many similarities in the beginning of the actual SHA1 function and the MD4 function. So in the beginning, we might be copying a good amount, as I explained. So next, after you grab the conversion, you're essentially going to do the same thing and append one byte to the end of it. So in reality, I'll just grab this function and do the same thing. So what we're doing here is that we're adding a 1 to the very end of this message after it's been encoded with UTF-8. After that, I believe we go into the padding. So like I said, for these ones, we're kind of going based off of this. Boom. From there, we pad it with zeros until it has a modulus of 448 by 512. We do that so that we can actually make sure that it is going to be the proper size when we continue on using the SHA1 function. But by the end of this, we're going to need a 64 byte word or 54 byte block, and we only make it go to 448 because with that last byte, we'll actually use the we're gonna append the length of the actual message to the end of the padding. That way there's a way to actually know, well, it's just how it goes actually. So next, like I said, we're actually going to go ahead and add the length to the end of this. So we're just gonna go ahead and copy this. I believe that one difference here, and I might just have to make sure of it, is that this would actually need, if I'm not wrong, to be in big endian format. So I'm not 100% sure if this truck pack is doing that. It might actually be doing little endian based on this less than sign. So instead I will type in this command, well, not really a command, and that will be the appropriate way to do this. Now after that, similarly to what we did in MD4, we're gonna break these up into 64 byte blocks so that they can each go through the transformation process that actually creates the hash. Because like I said, there can be times when your message is extra long, and if it's extra long and it breaks past 64 bytes itself, you would then have to create multiple 64 byte blocks and then go through the hashing function with each of those blocks, and then at the end add them all back together using bitwise addition. So from there we've created the 64 byte block, and now we can actually get into the meat and potatoes of the SHA1 function. So what I showed you prior, it seems to be a prelude to most of to many hashes, it looks like, because I was also doing some research for the MD5. It looks like it might start off the same way as well, but I digress. So we've now initialized this in a way that it can be used and gone through by the SHA1 function, which we will create now. SHA1 underscore, we're gonna call that function the. I will need here at the self. No, we don't even need a block. So boom. So we'll start off here. Now, kind of in a similar vein to MD4, we're going to start off with some some variables that as we go through will constantly be transformed to output something completely new at the very end. Now, gonna hit them with some of these, this, and this. Now, as you can see, as compared with MD4, which had 4 functions, this one, I said functions, 4 variables, this one actually starts off with 5. Now we're gonna go through and make changes to each of these and then bring them all together in the end, but we are going to need this moving forward. Next up, we can actually call on the blocks created by the function here, and then from there we can actually start our function, our for loop. I said function, my brain is confusing words, but we can actually start our for loop. From here, I'll be so honest, it looks like it's already coded everything out that we're going to need, so we should be good on this front. I'll go ahead and tab it all in. I'll double check if there's anything we're missing, but I think we should be good here. So it does look like we're good, but we're gonna have to go through and get some functions set up, but we'll do that soon. So essentially what this is doing, it is breaking up these words into big endian blocks of, is it 32? Yeah, 32-bit length words. So it's breaking it up into 16 32-bit length words. After that, we have our original 16. Now with SHA1, this is where it really begins to differ from MD4. Instead of going ahead and starting with these broken up 4-byte words, instead we actually have to add on more bytes until we have 84-byte words, as compared to what we did previously where we only had 16 4-byte words. Yes, so to actually create the 84-byte words, we go through this function here where we're actually gonna XOR different words within the list and then rotate it by 1. Now, for this one, we're actually going to go ahead and create this function now. I didn't do it prior, but we'll go ahead and create it now. So we're gonna actually come back to the top. Once we get there, we're gonna go ahead and create this left rotate function. So this function is actually going to be the same as before. So let me actually just go ahead and copy it from here. Okay, so from here, after it creates the 80 different words using these XOR functions and the rotation to the left by 1 bit, we then create the A, B, C, D, and E variables, which initialize as the variables we had at the top. Now what's going to happen is that as we go through this, the letters A, B, C, D, and E will continuously transform, but we can start talking about that now since it's actually happening at the bottom. Another way that this actually differs from the MD4 function is that instead of going 3 rounds, this one actually kind of goes 4, but let me break down how it's a little different there too. So in the original MD4, there were 3 functions that do the transformations, each of them having their own constants, each of them having different functions that actually work differently, and then going through and doing them on each of the 16 words 3 times. Now with this one, it's a little bit different. So as we can see here, instead of doing it on every single word and then going on every single 4-byte word and then going on to the next round, what it actually does is that it breaks up the rounds into essentially 4 rounds of 20. However, it breaks it up into 4 rounds of 20, and that way an effect can be had on each of the 80 4-byte words. So for the first 20 bytes in the for the first 24 byte blocks within this transformed message, we're actually going to go through, create this F variable by doing an OR statement on, well, let me read it straight through. So first we get B and C, and then we do a bitwise AND with them. On the other side, we do the reverse of B, or not B, and we do a bitwise AND with that and D, and then finally we do a bitwise OR with those words, with those expressions essentially, and then put it together into our variable F. Now as we go through, well, with the first 24 byte blocks, this will continuously happen, and then after each block it comes to the bottom and does something similar to what MD4 did, in where it actually shuffles the variables into each other. So if we take a look here, so after, let's pretend I'm on the very first 4-byte word. In the very first 4-byte word, what's going to happen is that we're going to take B and C, in this case H1 and H2, and them. We're going to take the not of B and then D, which are H1 and H3, and then AND them together. From there we do a bitwise OR. Now once that bitwise OR is actually accomplished, that F becomes a part of the function to create this temporary variable. And then we actually add it with the E, which in this case it is H4. We do a bitwise addition operation with F, E, so F is what's up here, E is H4. K is a constant that we have placed within each of the first 24 byte blocks, and then W1 is the actual byte that is being used. So in this case, we're talking about the first byte within the message block, the first 4-byte block within the message block. And then finally, we remove the excess numbers that aren't needed, and then that becomes temp. Now, with this, we also add something here, after rotating A to the left by 5 bits, that's also added to the rest of this equation, and that's actually then made into temp. Then from there, this entire equation is stored into A. Well, let's do it in order. So we have temp now. So D is moved into E, C is moved into D. Now B is also moved into C, but before it's moved into C, it actually does a 30-bit rotation, left rotation, and then it's stored into C. Now B is A. When I say B is A, it's actually the original A, which is H0, and then A becomes temp. The reason I stopped earlier was because if I had said temp becomes A and then A becomes B, it would have messed up the order, because now A is no longer H0 and it's instead this temp variable that's stored in B, but that's not how it goes down. So essentially this continuously happens within the function of this range of 1, well, it's supposed to be 1 to 20, then 21 to 40, 41 to 60, and then 61 to 80. So these transformations continuously occur until everything is essentially mixed around, each word has had a singular transformation, and it's all been shifted as needed. Now once that's done, what you're gonna do, as we did in MD4, you essentially grab the original elements, which are these variables up here. Oops, if I can grab them properly. And you add them to their corresponding variable down here. So in this case, we're gonna set H0 now to be equal to the original H0 plus the A that has been transformed now 80 times through the rounds that it's been doing for the SHA1 function. And then same thing with H1B. So H1B, H1 is added to B, the original H1 plus B that's been transformed, and then so on and so forth. So once that is done, let me actually check something. Yep, okay. So once that's done, what we have to do next is concatenate these words together. So we have to get H0, H1, H2, H3, and H4 and put them all together so that we can end up with, if I'm not wrong, I think it's a 40-byte word. Let me see. I might be getting that one wrong. An 80-byte hash, actually. So it would have 80 bytes. But back to this. So we're gonna return. Yeah, I think this is fair. So what this is doing essentially, it's returning these words on this join function by doing for x in this little list here. So yeah, x is then turned into, if I'm not wrong, I believe this is just a hexadecimal. So x is transformed into a hexadecimal format, and then it's joined together by whatever's before it. So H0, in this case we're not doing a bitwise addition, we're just concatenating it to the end. H0 and then H1 and then H2 and then H3 and then H4. Now for simplicity purposes, we're gonna imagine H1 is 0, H1 is 1, H2, like the values equal 0, 1, 2, 3, and 4. So in this case, when we're concatenating it, it's going to be the number 0, 1, 2, 3, and 4. So it would come out as looking like 1234 with a 0 at the front of it. So that's essentially the end of this function here. And with that, we're going to call a final function that calls this function. And then once we do that, we'll be able to actually return the hash value for SHA1. Now let's save this. We're gonna save it as SHA1. Save it down. Boom, and that's it for SHA1. Now it's actually time to test out if this works or not. So we're gonna come to test. Essentially, we're gonna copy this format. So convert SHA1. See, the computer already knows what we're trying to do, but of course I have to actually import SHA1, SHA1, and then actually save this. So now that that's complete, once we print this out, it'll now print out the hash value for MD4, NTLM, and finally SHA1. So let's try to run this. Okay, boom. So for each of these are converting hello into their SHA1, into their hash counterparts. So for proof's sake, we'll go ahead and find a SHA1 generator. So I'm gonna move this over here. And now we're gonna type in the word hello. We're gonna hash it. And this is the result that we are returned. This is the result that is returned. From here, we can copy and paste it here and then compare what we have to make sure that this is correct. And if so, it means that this SHA1 function class actually works properly. So going through and looking at it, it looks like it is similar. AAF4C61, AAF4C61, and then we're gonna try to grab the last few. So AEA943, AEA943, and then 4040. So it looks like we were able to successfully mimic now the SHA1 transformations, and from there it looks like we just have one more hash function to go to actually complete our password cracker. Like I said prior, this is going to be a simple password cracker. There are much more functions that we could go in depth with, but I wanted to start off with a few basic ones so that we could actually test it, play around with it, and get more comfortable using it. But for right now, that's the end for SHA1. And our next one will be actually building out the class for MD5. And then from there, we're gonna be putting it all together so that we can build a Python password cracker tool that's similar to Hashcat that is able to run through a list to determine if an acquired hash is actually equal to any value within that list. But I'll leave it there for today. Hopefully you guys enjoyed the video. If you guys are enjoying these type of videos, let me know. If you like the video, go ahead and like the video. If you like the type of videos that I'm posting, go ahead and hit that subscribe button. Like I said, we have a whole bunch more exciting projects that we're going to be doing, a whole bunch more hacking, a whole bunch more defending. And if you want to come along for the ride, say I'm not going to stop you. If you didn't like the video, please let me know why you didn't like the video, because like I said, I'm trying to improve. I'm just getting started, but I want to know how you guys are feeling about these. And if you guys have any tips, any criticisms, let me know, because like I said, I'm trying to grow. With that, that's all from me. Hopefully you guys have a beautiful rest of your day. That's it. Novice out. Peace.